So in this video, I'm going to talk about a drop-in replacement for a mouse that's intended to help people with repetitive strain injuries in their wrists who can't use their hands normally to operate a mouse. Maybe they can use a keyboard, maybe they can't, maybe they're just using speech recognition, but mouse input is a real problem. There's no real equivalent to speech recognition but for a mouse. So we need something like that. We have alternative mouse technologies like mice that you can use with your feet, and mice that consist of a webcam placed on your monitor that looks at you and, for instance, analyzes your facial features to determine which way your face is looking, using that to position your cursor in an absolute sense on the screen. So if you're looking to the left, the cursor is positioned on the left of the screen. And there are also some that use infrared lights to shine. You stick a reflective dot in your forehead and it tracks the reflective dot. Some of them track gaze. All of these techniques have downsides, some of them quite major. The biggest one that bothered me as an end user was the enormous amount of latency or lag that was introduced by all the computer vision techniques needed to do these things. So, for instance, if you move your head to the left, you move your head and the cursor slowly drifts to meet where your head's looking. That makes it pretty hard to work at a reasonably high level of efficiency, of productivity, because this closed loop that's supposed to exist between you and your input device, you're supposed to be able to move the mouse and see the feedback, and you're operating in this closed feedback loop with your input device. That loop is very it's a very large loop. It's a long time for a round trip, so your productivity goes way down. So I've got a proposed solution to this, and it's kind of turning this paradigm of a webcam looking at you on its head. Now you attach the webcam to yourself and you have it look at something else. So I've got my webcam here, which is Microsoft LifeCam 5000, I think. And it's attached to a bicycle helmet because I need some way to stick it to my head. This is not the most elegant method. I'm sure you could do a lot of other things. You could have some sort of headband that you could attach it to. Maybe you could get a very compact webcam and embed it in the frame for glasses. There are lots of different things you could do to make this more elegant. This is just a really rough prototype. So I have this helmet, essentially, that I put on, and you're not going to win any beauty contests wearing this thing, but it's really intended to just let you get back into working when, you're just totally toast because of RSI. So right now I'm moving the mouse with my hand, but I'm going to show you here. I have the code that I've written to take the images from this webcam and interpret that information to position a mouse on a screen. Once I run this code and minimize it, I'm going to be using the mouse entirely with my head. So from this point on, this video right now, I am no longer touching my mouse. Everything that's happening is just my head movement. So I can move up and down, I can move left and right, I can move in big circles, whatever I want. So this window here shows what's actually happening. I'll minimize this maybe so it's not so distracting. This is my recording console. So here this window shows what the webcam is seeing on the left. So this is actually my room and the wall here. I have this black bag up there, which is what I'm tracking. You'll notice there's a lot of extra noise stuff here in my background, like I've got this sort of scroll on the wall. I've got a calendar window, my monitors. But this black bag here is basically all you can see in the right-hand side of this image. So what's happening is there's sort of a hard thresholding where anything that's not sufficiently dark is just discarded. So only this black bag shows up. And basically it's finding the center of this black bag, and for technical people, for computer science people, this is ridiculously simple. I'm doing hard thresholding to throw away anything that's not below a pixel intensity of 40 on a scale from 0 to 255. And then I'm running a breadth-first search on any black pixel that I see. So this is linear in the number of pixels that are black in the right image. And I'm ignoring any sort of clumps of pixels that are either far too big to be the bag or far too small to be the bag. And so there's kind of a range for the size of this bag that's just a manual input to the program right now. Maybe I'll make it sliders, maybe I'll make you able to click the thing that you want it to track when you start the program. So the way that this works is it finds the center of the bag and it uses that to absolutely position the mouse on the screen. So if I look at the bottom left of my screen here, then you can see I've looked a little bit too far there. You can see that this red cross is in the top right of the screen. The bag is in the top right, so my mouse is in the top left, is in the bottom left. This corresponds to me looking down and to the left. If I look up and to the left, you can see, up and to the right, you can see what's happening here. So it's a very, very simple algorithm. And under my desk, I've got a set of foot pedals. So 3 foot pedals, 1 for each mouse click here. I'll use the keyboard for a second. I'll show you where I got these. So if you go to ebay.ca, and if I go triple pedal keyboard, oops, that is not what I wanted, pedal keyboard, then you can see this guy. This guy is what I've got under my desk. So if you shop around, you can get this for 20 bucks after tax and shipping. I've got the leftmost button mapped to my left mouse button, the middle is mapped to the middle mouse button, and the right is mapped to the right mouse button. So basically I've just got these 3 pedals under my desk and I'm using those to manipulate things. So I can grab and move around windows pretty easily, I can open a new tab, and if I've still got the use of my hands for typing, maybe I can't use a mouse, but if I can do some typing, then it's still pretty nice. And so I'll minimize that. So it's pretty easy to grab and move things around. It's pretty effective manipulating things. I'll minimize that for a moment. If I go into the code here, I'll just show you an example of how it's relatively precise, quite precise actually, as long as you kind of get used to having fairly steady head movements. So let's say I want to select this word cam1. I'll stop talking for a second because talking jars my head, makes it harder for me to move. There, that's cam1, W1, cam1, loop. And it's a lot more effective if you can use a keyboard to kind of just adjust where you are just a little bit. So, I mean, if I want to go quickly to that 640, I can just sort of click somewhere nearby and adjust with my keyboard. And I can click up here and go to, STD, or click down here and go to cam2 pretty quickly. So, it's pretty reasonable for textual manipulation. It's even more reasonable for just navigating interfaces. It's actually positioned a little bit too far down on my head, so I'll do that. So I can navigate pretty well, and the nice thing is I can do sort of independent navigation with my head and the keys, at the same time. And, I can right-click things, go into properties menus. If I want to do some stuff with, I don't know, properties for something, it's fairly high precision. I can do very reasonable things. So it's a pretty nice replacement for a mouse. I think it's a bit wider. Some very precise motions, like where you want pixel perfect accuracy, can be a little bit frustrating, but to be able to say, I can actually get pixel perfect accuracy by moving my head is remarkable. Your hands have a huge advantage when it comes to pixel perfect accurate tasks, and that is, when you want to move your hand very precisely, you don't do it holding the mouse with your hand only in contact with the mouse moving from the elbow. Rather, you put part of your hand on the desk and you do a minute adjustment by using the fact that one of your fingers is fixed to the desk and just moving something by using small muscles in your hand relative to that finger or two that is anchored to the desk. So you don't have that. This is just absolute, movement, free movement, and you're kind of using muscles that might not be used to doing this. But I think you can get used to doing this quite quickly. I actually became proficient with this. I would say I started to kind of get very used to this after using it for a couple days, maybe a week. I started to get a very good sense of how far I'd have to move my head to, actually go to the things that I wanted. But you can see that the actual feedback loops that I'm creating here are quite quick. If I want to just, go to that minimize button, the feedback is so fast, the latency is so low that I can get to it very quickly just relying on feedback. So it's quite nice. And I guess that's my demo. I'll conclude by saying that you can do a lot of fairly high precision stuff. In particular, something that's quite surprising is you can actually play games, even competitive online games, with this, provided you're willing to put in a little bit of time to figure out a control scheme that works for you. Usually you need more inputs than, a couple of buttons with your feet, so you might have to do a little bit with a keyboard. But if you can choose a couple buttons so your hand doesn't have to move, you can do that, pretty low stress, and not using a mouse, you can substitute the mouse for this head movement. So I find it works pretty well in slow-paced games, and even in a couple fast-paced games. So at some point I'll make a video to show that that's actually feasible.